Arithmetic sequences. Investigation 9. Pablo starts his first full-time job at the age of 24. In his first year, he earns $3,250 per month after taxes, or $39,000 per year. He is given a salary schedule that shows how his salary will increase over time. In his first year, so years in job, the first year, $39,000, right? That's $3,250 per month after tax. So that's $39,000 after tax in the first year. In the second year, he gets $39,900. Third year, $40,800. Fourth year, $41,700. And the fifth year, $42,600. So it's increasing. Now, can you see a pattern with the increase? We can also write the salaries for each year in a list like so. Just put them all in order like that. 39,900 and all the way up to 42,600. We call this a sequence, an ordered list of numbers. We call each number a term. That's term number 1, term number 2, term 3, and so on. It is helpful to have a way to write, for example, the 13th number in this sequence. We use a letter and number combination for this, such as A sub 13. So in the sequence above, A1 or A sub 1 equals 39,000, also called the first term. Second term is written like that. That's the notation. That should be 39,900 there. 39,900. That should be a 9, right? And the third term, 40,800, and so on. In general, A sub n is the nth term. The entire sequence is denoted by parentheses, A sub n parentheses. Okay, let's have a look at question 1 here. This is in the investigation. That's our table. Write down the fifth term of the sequence above as a number and in the notation. Okay, we can do that because we know that this is the notation. So that's the first term, second term, third term, fourth term, fifth term. So we would have the fifth term equals 42,600. So they want the number, which is 42,600, and the notation, this notation here. So A with the sub 5 equals 42,600. Okay, it says for number 2, use technology to graph the sequence, which I've done over here. The independent variable is the term number, 1, 2, or 3. So we've got that along here. And the dependent variable is our salary. So I started in my Inspire and put A for the you can't see number 1 here. I've scrolled down, but that's the term number, and this is the salary. And then I went to data and then quick graph, and I plotted it here, and that's our term number, and that's the salary. Okay, we've done that for example there. What do you notice about the graph? Well, it's a straight line. Why do you think this is so? Why is it a straight line? Well, because it has a constant slope, because the increase, I don't know if you've noticed yet, but that's going up by 900 each time, which means for every movement to the right, it goes up 900. Okay, and we know that rise over run, so this would have a slope of 900. 3, a sequence that forms a straight line graph is called arithmetic. So that defines it as arithmetic. How might we identify a sequence as arithmetic without graphing it? Well, if the increase between each term is a constant value, then it's arithmetic. And I should also add that if it was a decrease, if the numbers were decreasing by a constant term, it's also arithmetic. 4, complete the table by calculating the difference between every pair of consecutive terms. The first is done as an example. What do you notice? Does this support your conjecture? Okay, these are the terms or the years in the job. That's the salary. And the last one here, difference between the terms. Between term 2 and term 1 is 39,900 minus 39,000, and that's 900. You'll find the same when you minus 39,900 from 40,800, you'll get 900. You minus 40,800 from 41,700, you'll get 900. And when you minus 41,700 from 42,600, you'll get 900. So the difference between terms is 900, 900, 900, 900. So that means Pablo is getting an increase in salary every year of 900. And if we relate this back to the graph that we saw, it was a straight line graph because the slope was constant It was 900 divided by 1. The slope was 900. Question 5a, what is the gradient of the line formed by plotting the points of the sequence? How can it be predicted from the terms of the sequence? Well, the gradient was 900 because we saw that because remember on the independent axis, the x-axis, we had the years or the terms. So we had 1, 2, 3, 4, 5. And on the vertical axis, the dependent variable there, which was the salary, for every movement to the right, it was increasing by 900. And the slope is rise over run, so it's 900 divided by 1. So the gradient was 900. How can it be predicted from the terms of the sequence? Well, the increase, the constant increase or decrease, is the gradient. B, what is the y-intercept of the line associated with the sequence? How can it be predicted from the terms of the sequence? Well, I think they're implying here that the x-axis starts at 1. So that would be then 39,000. But if you look at my graph earlier in this video, you'll see that I started the x-axis at 0. Okay. So, but the year 1 is basically the x equals 0 point. And if that's the case, then the y-intercept would be where the term equals 1, which would be 39,000. C, find the equation of the line associated with this sequence. We can find that out because we know m is equal to 900, and we can work that out by putting y2 minus y1 over x2 minus x1 using 2 points that we have. For example, we've got 1 and 39,000, we've got 2, and we've got 39,900. So we could get m, and that's 900. Then we could put it in the y minus y1 equals m times x minus x1, and we could have an equation. Now that equation is going to give you a line similar to the one I plotted on the earlier in this video. Okay. But I hope you can understand that I think they're implying that on the x-axis, that x equals 0 is actually going to be our 1. And the reason we can say that is because there was no year 0. And if you wanted to represent that on a graph, you would have to change the points to be 0, if you use the calculator. 0 equals 39,000 and 1 would equal 39,900. That would give you a line that would have the y-intercept at 39,000. D, what advantages does representing Pablo's annual salary with a sequence have over representing it with a linear function? Well, as a sequence, it's quite clear we can determine that the change between each term is a constant, and that's quite clear when we put them in a sequence because we can use a technique of subtracting terms from each other, consecutive terms, to find what the difference is. 6. Pablo decides to buy a car but has to take out a bank loan to do so. Every month the bank charges him interest, a fee for the loan that he must pay. The table shows the amount that Pablo must pay each month. So in the first month he's got to pay 55, second month 52, third month 49. So these are the numbers we're interested in. A, find the difference between consecutive terms as you did before, completing the third row of the table. Okay, so what are the differences here? The difference between these two is minus 3. So it's minus 3. It'd be nice if this was in the middle here, but they've got it there. So I'm going to put a dash there like we did before. We'll put minus 3 because 55 minus 3 is 52. Again, we put minus 3 here because 52 minus 3 is 49. Minus 3, 49 minus 3 is 46, and 46 minus 3 is 43. B, call the sequence of Pablo's payments this. What is B1? Okay, that's the first term. Well, the first term is 55. What do you predict B7 to be? Well, if that's B1, B2, B3, B4, B5, B6 would be 40 because it's 43 minus 3, and B7 would be 37. What is the difference here from the previous situation? Well, now we're decreasing. The number is decreasing now. And what is the same? The same is the fact that it's a constant difference between the terms. 7. How do you determine whether a sequence is arithmetic without graphing it? We look at the difference between the terms, and if the difference is constant, whether it's negative or positive, it's arithmetic. 8. If a sequence is arithmetic, how are the parameters of the corresponding linear function related to the first term and the difference between terms of the sequence? The linear function is a y equals mx plus b, so our b is going to be the first term. Now, for that to be the first term, there is no change. So that's why they've got the 0 here. If we look ahead here, they've got the 0 because we're not adding anything. So it's just 39,000. So basically, that's our B. The mx is the slope times 0 in this case, and this is the slope times 1. And we said the slope was 900, so it's B plus 900 times 1, and that's 39,900. All right, 9. Use the pattern in the sequence to predict Pablo's annual salary if he stays in the same job and retires at the age of 65. You may find it helpful to complete the table. Well, let's have a look at this. That's term 1, term 2, term 3, term 4. Okay, now what's the difference between here? What's that going to be? If 27 is 4, 64 is what? Well, it looks like there's a difference between here just for calculating these two here. It's just 1 plus 23, 2 plus 23, 3 plus 23, 4 plus 23. So it's a number here plus 23. So it looks like it's going to be 41, and this would be the 42nd term. And then the number of differences, there's no difference because it's the first one. And then the number, there's 1, 2, and this one would be 3, okay? And then we've got all these ones up here. So this looks like one number less than that number. And we said this was going to be 41, so that must be 40. And that was going to be 42, so that must be 41. And so as we add these up, we can then calculate this one because we said that this is going to be 3. So that'll be 39,000 plus 3 times 900. Now this one we said was 41, and this was going to be 40. So this is going to be 39,000 plus 40 times 900. And this we said was 42. So this would be 41. So this would be 39,000 plus 41 times 900. 10. How can we systematically calculate the nth term of our arithmetic sequence? Well, we can develop a pattern from here. We can see that this difference here, we could, because there's a difference of 1, so we call the term number minus 1 would give us that. So that'd be n minus 1. N minus 1, because 2 minus 1 would give us 1, and 3 minus 1 would give us 2. So the formula is going to look something like, in this case, 39,000 plus the term number minus 1 times the gradient, or this constant between terms that is defined here as D, the difference between terms. And that'll give us this pattern. General sequences. A sequence of numbers is a list of numbers of finite or infinite length arranged in an order that obeys a certain rule. Each number in the sequence is called a term. The nth term, where n is a positive integer, can be represented by the notation u sub n. Sometimes other letters are used to represent the nth term of a sequence, like, as we just saw, a sub n or b sub n. There. For example, 3, 6, 9, 12, 15 is a sequence. What is the rule? The first term is 3, the second term is 6, and so on. So we can say u1 is 3, u2 is 6, and so on. Note that a sequence can be thought of as a function from, now these are positive integers, to real numbers, where the notation un is equivalent to un. So these are always positive integers, and these are real numbers, any real numbers. That real number is all numbers. Example 11, for each of the sequences, write down a general formula for the nth term. Well, this one has a difference of 2, so this could be it, the sequence un, the nth term is 2n. So if n equals 1, that equals 2. Well, that's true. When n equals 2, the term equals 4. So that's true. This is a sequence of positive even numbers. The terms can be written as 2 times 1, 2 times 2. And this one, this is 1 over 1, 1 over 2, 1 over 3, 1 over 4. So that would be un equals 1 over n. And B, write down or find the 12th term, and for the first one, they've got it as 24, and the second they've got as 1 over 12, and you can check that out in your textbook. Okay, here is exercise 5I, 4 questions. Use the example and the investigation to help you find the answers to these questions.